In today's video, we are going to explore how particles can form chemical bonds specifically through a type of bonding known as ionic bonding. This kind of bonding involves the transfer of electrons from one atom to another, which results in the formation of ions that are oppositely charged and therefore strongly attracted to one another. To help explain how this works, we will use diagrams known as dot and cross diagrams, which show how the electrons move and what happens during the bonding process. But before we get into the bonding itself, let us briefly review what ions are. Ions are formed when atoms either lose or gain electrons, and this can be described using word equations. For instance, a sodium atom will change into a sodium 1+ ion and release one electron. If we look at the structure of a sodium atom, it contains one single electron in its outermost shell, which it wants to lose in order to become stable. Stability in this context means having a complete outer shell of electrons, which is typically 8. Meanwhile, if we consider a chlorine atom, we would say that one chlorine atom combines with one electron to become a chloride ion with a charge of 1-. This is because chlorine needs one more electron to complete its outermost shell of 8 electrons. Now, while these changes can be shown individually, in reality, such reactions typically occur together, with one atom transferring electrons to another so that both become stable. This means sodium donates its extra electron to chlorine, which needs an extra electron to complete its shell. After this electron transfer, both atoms become ions. Sodium becomes positively charged while chlorine becomes negatively charged, and because these ions now carry opposite charges, they are strongly attracted to each other due to electrostatic forces of attraction. This strong attraction is known as an ionic bond, and it holds the ions together in a compound. Ionic bonds are very strong and can be comparable in strength to covalent bonds, which involve the sharing of electrons and are discussed in another lesson. The visual representation we use to show this process is called a dot and cross diagram. In these diagrams, electrons from one atom are represented by dots and those from another atom are shown as crosses. This distinction helps us easily identify which electrons originally belonged to which atom. Additionally, we should show the movement of electrons using arrows to indicate how they are transferred. In some questions, you may be asked to draw all the electron shells of each atom, but often you are told to draw only the outermost shell, which makes the diagram simpler and quicker to complete. For example, if we only showed the outer shells in a sodium and chlorine diagram, it would still be clear how the bonding occurs. Now, let us move on to a more challenging example involving magnesium chloride, which has the chemical formula magnesium chlorine 2. Here we need to draw the dot and cross diagram showing only the outermost shells. This compound contains 3 atoms instead of just 2. We begin by drawing magnesium, which has 2 electrons in its outermost shell that it wants to lose. Then we draw 2 chlorine atoms, each of which has 7 electrons in its outermost shell, and each needs one more to become stable. Electrons always move from metals to nonmetals, so in this case, magnesium donates 1 electron to each of the 2 chlorine atoms. As a result, magnesium becomes a magnesium 2+ ion, and each chlorine becomes a chloride 1- ion. This satisfies the rule of full outer shells for all 3 atoms. And cross diagrams with more than 2 ions, we usually arrange them in a way that reflects how they would be structured in an actual ionic compound. So in our diagram, we place the 2 chloride ions on either side of the magnesium ion, since they are both attracted to its positive charge. This visual layout helps reinforce the concept that in real ionic compounds, ions are arranged in regular repeating patterns known as giant ionic lattices, which provide stability and contribute to high melting and boiling points found in ionic substances. Ask ChatGPT.